So some of the people on the call probably know me. I've had quite a history with Capella. I started in 2017 and started using it. One of my first models was the solar charger. If you see it, you can see one of the solar chargers that I built behind me. I pulled it out of the backyard and brought it in for a presentation today. In 2018, we teamed up with Obio to deliver and develop our first product based on Capella called System Modeling Workbench. In 2019, I worked with students. I really wanted to test out whether it was something that could be done with younger people, and that was a really good success. They ended up winning a state championship in basically technology, which was kind of cool for the small team that was right here from town. They were middle schoolers. I've participated in a number of series of videos. I've been on Capella Days now a couple times, and Lunch with Larry series has been very popular. I think it's quite interesting. It's a series of a lot of our Siemens products, and to this day, it's basically 2 orders of magnitude of interest more on the MBSE topic over any other product. So it's over 10,000 views, which is very interesting. In 2021, I launched the Innovating with Capella series, and I thank people for joining that series. I'm up to over 800 subscribers now, and I've got a lot of videos, and basically the people that I've worked with this community has helped shape that content. And 2022, I did a nice presentation on system of systems modeling here. This forum, I've done presentations with Nkosi. Nkosi is still always a good place to get information on MBSE, and specifically, we try to keep Capella in that forum. And just recently did a co-presentation, co-presenter with the working group, and have a couple papers in for next year. So hopefully I'll see some of you there. So my topic today is a champion. I said a champion is a hero or a protagonist who excels in a particular field, and possesses exceptional skills and emerges victorious in competitions and challenges. I feel myself am a champion, but more importantly, I want to help others become champions. And one of the challenges that we get, some of the challenges we get into doing that with Capella is you have to go through various stages to get there. So basically the goals of this presentation today is to share what I've learned and help you become or help you develop champions. That's kind of my goal here. Thanks to Dali, I got some interesting videos here, screen graphics here on becoming a Capella champion. And in some ways, this is kind of what you have to do. Yeah, you have to get up there and hold it up and be the one willing to take some lightning bolts at times. Powering up. So basically, I'm going to cover the topic, and I'm going to do it first focus on building skills, the resources that you can use to become a champion and to help your team become champions at this. Then really kind of the next phase after you build the skills is starting to share what you learned. And that's really a phase that I've watched many people go through as I've brought Capella to our organization, is that you have to go, and to other organizations, is that you first have to, basically get the basic skill set, but then you also have to get ready to share your content to other people and other parts of the organization and just within the team that you're working on. And then finally, the next phase, and this is the phase that I'm focused on right now the most, is leveraging what you built. One of the things that has started with the Capella community is that we're able to start exchanging data because of some of the open source tools that have come on the market, such as Python for Capella, and the DBNets set of tools. And I'll talk a little bit more about that. And things are even going to get even better as we move into the SysML v2 worlds, and lots of things going on with SysML v2. But before I get started, I'm going to talk a little bit about my notation. I am going to be use operational analysis notation during my presentation. You're going to see diagrams and pictures. I'm going to basically use the operational capability diagrams to represent some use cases and the actors and tools that I'm using. Tools, and in some cases, it might be textbooks, it may be organizations. And then I'm also going to use operational activity diagrams to kind of capture operational processes that are composed of the activities being delivered by the actors and entities. I have gone way past the point of where I think in Capella terms at this point. So many times it's just easier for me to capture this information in this format. And then even once it's there, I can hand it off to other people and help them understand it. In our organization, we do use things like business process modeling notations, but I still find that having a rich model Capella model is a nice way to start. Okay, just a couple disclaimers. Presentation is not a comprehensive list of tools and add-ons. It's just a subset that I kind of found as being helpful for a foundation for getting started. And they're ones that I feel that most people should know before they really can get to that next level. And I do work for Siemens. I've been with them for 20 years, primarily in the requirements and the systems engineering space. I've supported their tools, and I still support their tools as a pre-sales and post-sales roles. And so you're welcome to reach out to me through their organization or through my YouTube channel. Okay, thank you very much. So now I'm going to get going here. Okay, so the first step is really kind of building skills. And with building skills, I'm going to focus on a couple aspects here: self-training, the things you can do, and the resources. Many of these resources you've probably already touched upon if you started your own path with Capella. The next one is instructor-led training and mentoring. There's tools available for that. There's commercial training available, and Siemens even has some training internally. We're slowly getting that training up onto some of our in-house learning facilities and bring that online, but it is available. And one of the things that I've done is I've actually put some of that material together. And then the last thing I want to talk about a little bit is around version control. So we'll talk about that. Okay, so the first part, building skills. The two textbooks are key to basically learning Capella. Pascal Rowe's book and Jean-Luc's book are both excellent resources for learning the tools. That's where I started. The next one is the open source MBSE videos that are basically created, many of them right here in webinars like this. And there's another option is a tutorial. There is a tutorial that I delivered at NCOSE. That's a good tutorial more around the system of systems modeling and some of the more advanced features of using Capella to build, in this case, it's a concussion detection system. And that's one of the resources that we use internally for Siemens for training, and I've used with customers. And that is going to become part of some of the Siemens Accelerator Academy as time goes on. Talking a little bit about the training. The training is very important that you get some type of training and mentoring. The Talus training I personally have went through myself and actually have participated in helping other organizations get it. The key thing here about the training is knowing how Capella originated and some of the history. You're not going to get from just you're going to get in a better quality, let's say in person. Myself, it's also where you are guaranteed to learn something probably in the first 15 minutes of live demonstrations that you won't get from other sources. That's just watching somebody do something usually is the way that you learn it quick. Another aspect though of this training and mentoring that I think is really important is that you're going to get exposure to probably one of the best papers that was ever written on this topic. This paper is Augmenting Requirements with Models to Improve Articulation Between System Engineering Levels and Optimize V&V Practices. It's a mouthful, but really this was the paper that came out in 2019. It was at NCOSE. This is really what I feel is one that was a turning point in Capella with the Capella community. It brought forward the concepts of capabilities to functional chains. And if you're incorporating Capella into your organization, this is key that you understand the power behind this. I've actually have had customers come to me and ask me specifically what is a functional chain, because they had been hearing about it from organizations that were using them, and then I explained them how they would work in SysML v1 type of terms, but it's a very powerful concept because of the fact of the richness that the functional chains have and how we can actually take functional chains and turn them into scenarios. So this is a really organizing principle, things that are covered in this paper, which wasn't published in NCOSE. If somebody doesn't have a copy of it, you can give me I can get you a link to it. It's around covers a couple major things: functional chains and scenarios, how they relate to capabilities. It covers some recursive development concepts around capabilities and functional chains. It talks about how textual requirements and models can live together, and then also it talks about optimizing V&V with functional chains. So it's been really a key piece of knowledge that actually led me to developing the Innovating with Capella course material that I put together, and it's up on my YouTube channel. because I felt that it needed a lot more. The content that was out there wasn't focused enough on this concept of functional chains, and that's one of the reasons why I drove to do that. The next thing is version control. The first, you give your models the respect of version control. It's very easy with Capella to connect it up to, it has eGit essentially built into it under the Teams menu of the Eclipse Teams. It's very easy to hook it up to a Git server such as GitHub or GitLab or Bitbucket. It provides a powerful safety net as you become a champion and you start building your models. It's incredibly helpful for snapshotting models. I wish I had used it when I was developing my materials for the YouTube channel. I hadn't become a user at that point for it, but more recently I have been using it with the training that I've developed internally, and I use with Siemens or for Encosi, and it allows me then to bring people to an actual state of a model and load that up, and that's really cool, because it can help people move along in the training material very easily. So definitely give yourself that the respect of that. Learn how to use it, and you'll find it very, very helpful. In basically, also it's just a great safety net. Also, cool things like if you want to go and explore a concept, it's very nice for that. And then finally, the next thing I want to talk about is this is step 2. Basically, now is preparing to publish. When you basically want to start sharing your models, you want to share them and get them out to people. So 2 things that I'm going to talk about here is to start with is authoring support, and the other one is collaboration. So the authoring support is something that I end up doing a lot with customers to help them through kind of the hurdles of using the tool and getting the tool adopted by their organization or accepted by their organization. Sometimes they want to see things a certain way, and it's easier to with some of the tools that are available, it's easier to make the content look like what they expect as opposed to trying to get them to understand exactly the notation that Capella may have. So 2 tools I found that have been very helpful for this is the Python for Capella, which is based on the Eclipse Advanced Scripting environment. These are great tools for doing this type of work, to basically bring the content to it. In this example, I'm going to show basically using Python for Capella to modify a diagram. So I'm going to show one diagram, and I'm also going to show another one of where I use it to enhance the content of the model. I think of using Python for Capella as ideal for when I basically want to be in the tool and I want to enhance the tool. So it really is a tool for the author who's developing the models and to enhance them. It's not so useful for somebody who's not an author, who's a consumer. So we're going to talk about alternatives for that. But this is a powerful way that you can help your author out and give them help, give them some assistance in possibly formatting. And in this particular one is a formatting example. So I'm going to go ahead and run the script for this. You should be able to hear the audio. Let me know if you have any problems with that. So now here's an example of authoring support that can be used to help your audience. In this particular diagram, you can see that it has a functional chain that's being depicted across an integrated PC example. This is an industrial PC example, and it's kind of busy. So one of ways that we could enhance this diagram to just help users see it would be kind of to eliminate the functions that we have on it. So I can eliminate the functions, and you can see here I've eliminated the functions, but now I really don't have a connection to this thread of functions or that are going through the system. So the functional chain is kind of now obscured because we don't have any functions to show the functional chain. Of course, we could go in and manually change color codes of the various connections between the system so that we could highlight the chain of functionality. So I could go in here and use the property tab to make that change of functionality. It could change the color code to match the functional chain, but that would be kind of a very tedious task to do that. So instead, you can use something such as Python for Capella to do this enhancement for you. And here's an example of where I'm basically just going to select the functional chain. I'm going to run the functional chain command to do this. This is a command that basically shows up in a right mouse click operation. and I'm going to run the command, and you can see now the functional chains are lit up and color-coded between the various parts of the system where the function existed. I can show that by just bringing back the functions and seeing that they are the ones that are relevant. So that's the type of thing you can do with the Python for Capella extension, and an example of how you can help the author basically get a higher level of quality in their diagrams. Okay, so that was one example, and let's say, and there's many more, and there's actually, with Python for Capella, there's a bunch of really nice example scripts, and I want to thank the teams with that supports Python for Capella for the help and assistance and even getting that one particular example together. The next one I'm going to do, I actually have posted on my YouTube channel. It's using AI to help build models. And one particular thing that was pretty easy to do was to use to integrate ChatGTP with Python for Capella. I actually asked ChatGTP to generate the code, and it did generate the code. I've had to update it a couple times since then because the APIs have changed, but that's what this example is about. And again, it's going to be around that same thing. So in this example of basically helping support the authoring process, I want to show how we could do that by using AI to help create content. In this example here, you can see we have basically, again, this industrial PC, and we want to enhance this with possibly some information that is very commonly available. So for instance, here's the PCI card, here's the HDDI drive, maybe over here we have an HDMI connector. I'd like to be able to enhance the information around the model, because right now, underneath this PCI card, I really don't have anything that describes it. So one thing we could do is basically, again, using a script to do this enhancement. So I'm going to basically select these objects here. Well, if I select them in the window, and I'm just going to go and run a ChatGPT-based utility that's going to go and populate that information. That utility basically runs and uses ChatGPT to generate content for each of those objects. And it's right now that you see down here, it is running, putting the information and populating it into the fields. And it's going to do essentially one object at a time. Just let it run for a second. And now I can go over and start looking at the object's description. Here's the description that was written for the PCI card. And of course, you can review it, make sure it looks right, and delete it if you delete it or modify it as needed. So this is a great way to get information populated quickly. Here's the one where it's still working. Okay, so I think you got the gist of that activity. So it's very helpful to use that to basically help populate content. And again, I think we're going to see more and more uses for AI in that. One of the areas I have been exploring is even adding functions. Can it help me write my functions that we have for an object that, to say, something is very commonly used and you want to just have some basic functions put together? So definitely some interesting things you can do. And this is just, again, through Python for Capella. The next thing I'm going to look at is I'm going to talk about is collaborating with others. Another key part, at some point in time, you have to start working with others on things. One of the powerful tools for this is Team for Capella. The advantage of a Team for Capella is that you can have multiple people authoring at the same time. Again, there may be people that are doing, and if you've ever read some old books called the Mythical Man Month, and books like that around architecture, a lot of times there's the surgeon and there's the assistant. And this is an example of where a Team for Capella could be very helpful, because you could have the surgeon going in there doing the key amount of the architecture, but then you'd have the assistant going in and doing some of the things that we were just talking about, helping improve the diagrams for readability, making the lines look right. So it's an example, again, where you can bring more people into it and collaborate on one design. Yes, and I have read the Mythical Man Month, and it's probably about 30 or 40 years old now, but it's still a classic by my parts. I'm sure a few of you have read that. Jim, are you there? Okay. Next, sharing what you learned. So this is the next phase of doing it, and jumping up to sharing what you've learned. is broken down in, I'm going to talk about model depiction, basically model markup and lifecycle management, documentation, and then I'm going to talk a little bit about report generation and how that is basically used for this. In the first part here, we're going to talk a little bit about how do you depict models. There's two very common ways that people use to depict models now. There's basically the publication for Capella, which is a commercial product that OBO supports that does a nice job of connecting requirements to your model. It also allows you to publish the models, and it uses a server for doing this publication process. An open source one that's a tool that you can use is the HTML documentation generation. This allows you to generate a website of information from a model. And again, you would probably use these models in sometimes conjunction with some type of configuration management tool. You don't have to because of the way they work. And that's how they kind of are connected together. And I kind of show them over here in the diagram of kind of connected separately. Now, another tool you can use is our Siemens product. This is a tool that I help support. This is basically allows you to publish your models to a PLM system or to the accelerator platform, as we now like to call it. It allows you to publish the models and basically get diagrams published to the model, and also objects that are lower to the model that are part of it can be published too. At a bare minimum, one of the nice things about this one is it does support markup capability, which is again part of bringing your models to people and sharing them with others. You want to be able to get that feedback on it, and you can go in here and you can actually mark up the diagrams, and it will collect the people that are making the markup. So it's a great way to kind of close the loop on model reviews and things like that you want to do when you want to. And it also gives you a user interface that you don't have to learn all the bells and whistles of Capella to do that. You can essentially go in and navigate through the model that's been represented. The next major approach I hear very commonly is people want documents. Documents is something that are still, many organizations have documents that they must deliver at certain milestones. The things that you always have to remember, though, when you have documents is that you need to figure out how you're going to configuration manage the document. The document itself is potentially out of date as soon as you generate it from the model. But it's still a very standard approach. The M2Doc tool is probably your best option for doing document generation, but it's also not the only option, especially now that we have tools that are coming online, like the one that was developed by the DB Nets and presented here in a webinar a few years ago. I think it was on a Capella Day event. And I started using this one. And I like this one because it's more about generating a report. This tool, again, uses Python. You can use things like Jenga scripts. And kind of the difference is that it actually is taking content from a model. And in many cases, the model is configured. It can be configured in Git, for instance, or in Team Center, using it as a configured source and then generating content out of the model. This approach works better and basically was presented here by Victor. It works very well with continuous integration, continuous deployment type of environments. Great YouTube video on this content. And it's been a very interesting learning experience, and I thank Victor for some of the help that he had given me when I was spinning up on this tool. But I'll show you an example of it. Now, this tool can work with Jupyter notebooks, or it can also work with a Siemens product we call SimCenter Studio that runs a Jupyter notebook environment inside of it. And I'm going to show an example of where this could be used and how it may be used. Now, in this particular one, we're going to generate an actor and node report from a model. So I'm going to start with a Capella model, and I'm going to generate the content from it.
Now, here's going to be an example of report generation. In this case, we're going to be using this model of a concussion detection system that we're going to be using. And from this model, we're going to pull information from the model that's here. For instance, we got information on the trainer, been populated here. We've got information on the helmet, it's been populated. The sensor has information on it that's actually being used for it. So we got a lot of information that's populated from different portions of it. We've got both actors and nodes. And also you can see here that we have information on the model related to the various mass and some other properties that are related to the sensor object that we've mapped to it. So that's all in the model. These models have been saved to Git. So you see here two different Git libraries. So now we're going to go over to SimCenter Studio view. Here's SimCenter Studio that we have for it. We can see here that we have one of the libraries has been brought in. It's actually being viewed in the Git view. I can go to kind of the file browser view here and navigate up and see that I have basically a model for the concussion detection system and the LoRaWAN library are both in here. And now what I'm going to do is I'm just going to generate a report. Now here's the report that they're going to generate. It loads up the models. See here, loading up the models, and then it generates, and it then uses some code that defines basically Jenga templates to bring the model elements in for the various types of model elements. I'm going to close that up, hide that view or not, and then I'm just going to run the model, this piece of this report, and it's going to regenerate from the repositories where they have these models are stored in. And you can see here it already ran, and it gives me a report on all the physical actors, even information on the ports that are connected to it. Likewise, you can see here reports on the helmet and on the sensor itself, sensing device, and you can get information on all those things coming out. So there's the physical nodes, and here's the helmet, and you can see even information on the helmet is coming through, some of the link information. Here's some information on property values for the sensor are coming through, and they're coming out in this report. So this is an idea of what you can do with reports versus documentation.
Okay, and the cool thing about reports too, again, we're using Python, and you could have the reports even generate content to PowerPoints, to Word documents, to web pages. So it's an option with that approach to again populate content in different places from one source and then sending it out. And again, by using scripts and templates and things like that, formatting in a certain well and throwing it out to let's say a website that you're going to put the content on, or let's say team some type of Confluence pages or something along those lines where you wanted to basically get the content out for people to read. And you can see how that could work very well with continuing integration and deployment type of environments, especially if you're driving those around functional chains and content like that. So, and it's even possible that you could use it to generate information from functional chains that basically were modified and do updated reports that way. So it's very exciting, what you can do with that. Here's another example that we're going to walk through. This one is basically demonstrates a comparison and roll-up report. It's actually going to take 3 different models and put them side by side and look and generate a report. It actually is going to then do a roll-up calculation and update those models. And it'll do those all in one report. So this is a powerful tool, again, because it's stepping back and actually working with multiple models and doing it. And the models that I'm using here are basically, if you've ever seen, there's some FireSat models that have been out there. This talks about different architectures for this FireSat, which is a satellite system, and it's basically depicting some of the properties of the FireSat, the weight properties on the model.
So in this model, we basically want to do a roll-up and comparison report. So here we're basically going to use the value. We're going to have these different types of arrays. There's 3 different models that are being used here. Each model has slightly different numbers for values and properties of things. And then we want to basically compute this updated mass object here for each of these. And we want to basically update the model with this new computed value. So we start basically with the model representation that has the uncomputed value in it. Then we are going to go over into SimCenter Studio and model environment. Again, we can see we have 3 different models being used here. We have one for the body, one for the 1 axis, and one for 2 axis. We'll see in the calculation, we're actually going to load up all 3 models and use those 3 models in the calculation. So we're going to go here and we're going to run the model, and we run the model. It loads them up. It loads the models and the diagrams. So you can see the diagrams are being put on here. Puts the diagrams together. and then we do a computation. Those values are then computed for the total mass of each one of those things.
And then those models and that calculation can be basically saved back to the original model, and then you can open up the original models in Capella, and of course, working with your repositories, you get the most recent versions of it, and you can see the updated values in your models. So again, very powerful capability of doing roll-up, and a lot of potential there for using to compute some things that may be parts of a model. And I'll show another example that kind of does a similar thing kind of in this next phase. So in the next step, we're starting about leveraging what was built. Up to that to now, we basically are using it to kind of enhance the models and use it for communication purposes. But now we actually want to leverage and use it. A couple things that we're going to do here is we're going to talk about, first of all, life cycle and retrieval of models, basically getting the models that have been basically previously built. We're going to talk a little bit about verification and the various tools available for verification. And then we're going to talk about even the next phase, and this is where I'm spending a lot of time these days, is leveraging the downstream capabilities, basically pushing your system model to organizations that may be working downstream, or you're taking the downstream information and pulling it into the systems model. Believe it or not, that's a pretty common use case too, is that you want to use content that already exists. So the first part, I'm going to show just a short video here of basically what we can do with our Teamcenter product as far as using it to locate models that have that may have been matured or well formed, and basically want to reuse it. You may actually have libraries that you want to go and bring into a project to start working on. And so we'll do just a short video of basically doing that. So here you see me going in, and I have a search bar. I'm going to put in a search for an IPC. Again, I can go and locate. You'll get a list of the models that are available in the Capella format. Then you can take the model, you can open it up, take a look at the model, look at the contents of it, know if it's the right model that you want to use. Once you know it's the model you want to use, you can basically take that model and just go ahead and launch it into Capella. In our case, System Modeling Workbenches are our tool that basically has Capella built into it. That will then bring the model, load the model up into your Project Explorer area, so then you can start working on that model that was basically saved away. So it's a great tool for when you want to life cycle and manage models that have reached a degree of maturity. It also gives the ability to view it before you load it, that you don't really have with something like Git. So it's think of it as a way. The difference between it is that you could take your models that you may have worked with Git or you've collaborated on for Team for Capella, and then you can save them into the PLM system when they get to a degree of maturity, and then basically share them with a much wider audience in the world that wants to basically see them or be able to get access to them. Okay. Thank you. And that one. The next one is basically getting into verification. I've worked with one particular one. I have worked with the PGM code before. It does code simulation that it actually allows you to embed the code into the Capella model. Some people don't like that because now you're taking your model, you're putting code in the model, which is making it not a descriptive model, it's an executable model. I totally understand that. So that's the PGM product, but it's dynamic execution and system simulation. Very, very good product, and basically has been a partner of Siemens at various points in time. The next one is the Talus Capella MATLAB integration. As of this presentation, it has not been released yet as an add-on, but it is a good example of what you could do. In its case, it allows you to take the information that's in the Capella model, export it out, load it up into a MATLAB model, and then run the simulation there, with basically the simulation content being in the simulation model. The cool thing about that model, this implementation, is it does move state machines back and forth. So it's a great resource. I'm hoping at some point it does get released as an add-on, and anxiously awaiting for that to happen someday to get my hands on it. But in the meantime, there's other things you can do along this way. So I'm going to give an example of that. There's things that you can do with the open source community, and this is a direction that I've been looking at quite a bit recently. I've been working with a university that's doing some modeling and simulations, and one of the tools that they use is an open source tool called Gazebo. and they use that for integration with models. In this particular instance, I'm not using a gazebo, but I am going to show a slight demonstration here of how you can do this, this example with an arrow model. In this case, the model basically the ideal would be is that you'd have a requirements engineer who creates requirements, is basically going then go to a system modeler who's going to model those requirements into the system. The system modeler then would ask for maybe create a workflow that would send over information to a system engineer who would then do some type of verification of the model against some measures of excellence. And the example we're going to use here is a range example where it's going to do the range of the model and make the modification to it. And then there's going to basically do the verification of it for the range of this drone and then feed that information back to the system modeler. I'm going to focus mainly on this portion of this model for this, just the subset down here. And I've represented kind of the workflow for that subset. I'm basically going to have the system engineer, system modeler is going to route simulation, route to via a tool set to a system engineer who's basically going to do the simulation. I'm going to basically walk through the steps here of just running the simulation and then storing the model back. And that's kind of the main part of the workflow. In this case, I'm going to use a Jupyter Notebook instead of the SimCenter Studio. Again, you'll notice here the user interface is very similar to do this.
So in this example, we're using a Jupyter Notebook. Again, very similar to what we did before. And we've actually pulled information that was in the model. And in some cases, the model about some values were calculated from requirements and placed in here. The minimum range, some realized physical mass, and some of the min power capabilities were basically pulled in here. Have been pulled into the model. And that information then is going to be used to then calculate a range value. I'm basically going to go and grab the information from the model. That model then is then used to calculate and basically do a really simple range calculation. The range calculation could be as complex as you really ever wanted to do. Then from that range calculation, you could do a test to see if it's within the range requirements. And in this case here, just run the model. It'll rerun it, pull the latest information from the model, even the diagrams, and update it, and then give you a verification test on whether it passed or failed. And here's the calculation, and basically it says that the estimated range was 22.0, therefore it's a fail or passes. Okay, so that's the extent of how you would do it with an open source simulation model.
So it gives you an idea of what you can do with a simulation tool like that, and I see a lot more potential for that as we go along in things. The next thing is leveraging downstream. So this is simulation is an aspect of basically getting your model correct and adding detail to it. The next thing was how can I basically leverage information downstream, and what I'm going to do is show a little simple example here of using a DBC file. If you've ever worked with the CAN bus, you'll know that DBC is the format that most CAN buses can be represented in. Different tools have proprietary format. The DBC is one that what started out as a proprietary format, but there's open source tools that allow you to generate and read them, that especially in the Python arena. And so an example here would be to basically take this DBC file and have it be read, and it can be read. Basically, the designer could create the DBC file. The network designer here, for instance, could create it in a network design tool that they may be using, and that network design tool can then take the DBC file and save it away in the GitHub. Then the system modeler can then come here and again use the information and pull the information from the DBC and put it into a library for the model. And in the example that I've been working with is I'm pulling the information from a DBC file and populating a library model, Capella library. And then that Capella library model can then be added to a model that basically is developing, let's say, a new feature for a vehicle or an aircraft or some type of mechanical device that's using a CAN bus for it, maybe even a medical device. And so that information can be used to develop that new feature using the CAN bus information that has been pulled in. They could, of course, they may need additional signals. That additional signals could be created in this library, in the feature model for it. And then you could run some reports, again, using Jupyter Notebook to run reports on the differences in signals. That differences in signals, again, could then be fed back to the network designer, basically to create the differences in the bus design that they have to add. So kind of a workflow around leveraging the content that already exists. Think of it as the DBC file being the single source of truth that then is being used to basically modify and create signals in the system model. And likewise, it could be used the other way around. A little more detail on the example that I just described. Here the bus designer is creating essentially the DBC file. That DBC file then is being used to create some models. Here's your system model view. Here's your feature model that you might be building with it. And then once that information is created, then you could use reports to basically generate information on the signals. And then you can even generate reports, relevant to various ECUs. And then again, that can be fed back to the network designer for incorporation into the network. This is all use cases that I'm actively working on now. And one of the reasons I'm looking at this is that DBC is a standard. We are right around the corner. We are working towards SysML v2. And SysML v2 also is a standard. And it's a standard that can represent many things in the system engineering space. And one example is that kind of information around signals and networks and things like that. So we see this as that's basically the starting point of kind of a vision to have SysML v2 kind of as being a common description between the conceptual design world and product engineering world. So that's the future, and it's coming fast. We look forward to it, and I look forward to helping the Capella community embrace this SysML v2 world in the next few years. So thank you. This is kind of summarizing now. We walked through the different phases here of building, sharing what you learned, and leveraging what you built. I hope you can help power up your champions. I want to really make a thank you to the Capella community, the people that have helped me along the way. Talis and Obio and Pascal for his great book, and Victor for the tool set of PyCapella. And I also want to quick thanks to my family. Yes, my solar charger was on Hoover Dam. I took it out to see it. Happened to be in Vegas, and we had it there for a demo. My whole family has put up with me talking about Capella for many years now, and about what it can do and the fun things that you can do with it. So thank you very much for the presentation, for listening today. If you need to reach out to me, you can find me a number of different ways. I really have enjoyed this forum, and I look forward to your questions and answers. Back to you.
Thank you very much, Tony. I think it was a really great presentation, and I'm very sure everyone here really enjoyed it. You had really nice scripts, I found, especially the one you wrote in Python. Let's see if we have a couple of questions. I'll show you. You should see it on the screen. So the question is, how did you learn Python for Capella, and what resources did you sorry, it's me who typed the question and I made a mistake, but what resources did you find helped you the most for that?
Python for Capella, I basically, of course, I downloaded the materials, looked at the website, pulled down all the content I could add from it. But one hint that somebody gave me that I didn't see anywhere else was just ask help. One of the strange things about Python is it is an interpretive language, and you can just put in help in an object, and it'll give you all the API calls on that object. And so that little piece of knowledge was I missed somewhere along the way because I didn't take a formal class in Python. And just knowing that, was a huge help, because then you could go and you could write a piece of code, start with a script maybe that somebody already had. A lot of times I started with the Python for Capella scripts that were provided. I started with one of those and started tweaking it. But then sometimes you'd want to go and use a different API call. and I would go to the manuals and I'd look them up that way, and it'd be tedious. But then somebody says, "Oh, well, just put help in the object, and it'll give you all the valued calls that you can make to it." I'm like, "You can?" And that was an eye opener. And once I was able to do that, then it was very easy to start building pieces of models for and adding onto models. And there's also, and again, there's resources. The community that supports Python for Capella has been wonderful. I've been able to reach out to people and get assistance when I needed it. But it actually, again, people that know Python, they would have known that one functionality long before I did, and I felt very silly once I finally figured out that's all I had to do to learn how to do some of these things. But I have been a coder. I've coded for most of my. Let's just say I snuck into a Radio Shack when I was in high school and wrote my first program on a computer that was sitting there. And wrote my first Hello World program. So I've been programming for a little while. So.
It's still quite impressive that you could learn Python for Capella without knowing Python before. That's actually even for those who know it, it's not that easy, I think.
Python, it wasn't, considering Ada or assembly language. Yeah, Python was pretty easy.
Okay, thank you. Next question by Helder. For the three models and computed values, is it possible to verify compliance between them?
I'm not quite sure what you mean by verify compliance between them. Could you check between values of them or compare between them? Absolutely. I mean, that would be very easy to do because, again, you're just bringing values in and matching them up. Could you do a difference between the models? Possibly. It's probably possible you could do something like that, but I have not tried. I think more typically, how the use case came up from my particular case. I was asked, could I compare products that we have in our product line between and basically build a comparison tables between these various products and then present that as a management view. And that was where this kind of started from. And then I used the Firesat model that I've seen before. And you can do much more than what's there. Than what I did in that example where I just brought a table. You could actually run things through calculations and again feed the information back to the model is what I was doing. So, feel free to reach out to me if you have some more details, Helder, on that, and I can try to understand exactly what you were asking.
Okay, thank you. Yeah, Helder, you can, as Tony said, you can reach out to him, or you can also indicate in the chat if that's wasn't really your question. Let's see this one. So, since many small organizations are not using Teamcenter or Teamcenters, Teamcenter, but still want to get into Capella and open source simulation, what is your champion advice for such a road?
I think it's very easy to. I mean, and I kind of walk through some of the stepping stones of it. Number one, you want to get on Capella, then you want to get onto some type of open source or some type of Git version management tool. You want to have that as a minimum because you want to be able to get things configured. Once you have version control, then you could use things like the XHTML add-on to basically create a snapshot of the model. And then you could go with Jupyter Notebook as a way to basically end the Python for Capella, or not the PyCapella MBSE library that the DBNets team used. And you could use that as a minimum starting point for doing this type of starting point for things. The nice thing about all those, I mean, they're open source to get started with. I think in the future, you're going to see SysML v2 as being kind of right now, what's interesting is I'm using the Capella model as the kind of the source of information. And then I'm using, PyCapella MBSE in many cases to get the data out in using the APIs. You'll be able to do the same thing with SysML v2 as it becomes more mature and be able to get information out of the model in that format. the advantage there is that then you would have other tools could produce SysML v2 content, and you could do the same type of thing for it. But I think as a starting point, I would, if you went through the examples there that I walked through in this, you basically up to step 2 and even to step 3. The example I was talking about with the DBC file, that will probably be something that I'll be able to do completely without any of the Siemens products at that point, to be able to do that as a starting point. And then we'll work towards bringing in how you would do that with the Siemens tool set. Again, it's great for small organizations. Capella is a great product for it and a great place to get started. And one of the things I've found that it's very useful is that it's easy for people to kind of understand. It's not a complete change. I actually teach SysML v1, and one of the challenges is, well, why isn't there a function? And I can explain why there wasn't a function, because I was around during the wars that they had around functional decomposition and UML and all that stuff, and why functions were kind of voted down and kind of disappeared from things. And it's kind of funny when you think back and reflect on some of the crazy things that happened 30 years ago in the UML on the way to UML, and some of those did come back and actually impact our system engineering community along the way with it. So anyway, good topic for sharing a beer over sometime. Okay.
How do you connect OpenAI with Capella? Do you see other application of AI within Capella or MBSE in general?
How do you connect OpenAI? It's actually pretty straightforward. Like I said, I'm sharing my screen still. That's good. Let me just I'll move some things around here. My YouTube channel, I do actually cover an example of it, but unfortunately, it's a little out of date. The one in the YouTube because they changed the API call for a while ago on it. But basically, I asked ChatGTP, how do you connect to how do you use Python to connect to an API for it? And let me see if I can find it here. Oh, there it is, Python for Capella. And open up the sample script for it, and we'll take a quick look at it. And it's pretty straightforward. The key parts of it is you basically need an organization and an API key. So you'll have to get that from ChatGTP. And then the next part is basically there's code here to do a prompt and a response. This is what interacts with ChatGTP. You have to have the library incorporated in it. There's the OpenAI library. You do this is what they provided me in the code of how to do it. And then even give you an example of how you could decode it. And then what I do in my case, I basically just use it and then I set the description object with it. So pretty straightforward to do it. Again, this is just a handful of code, and the code could definitely be optimized a little bit. But the key part, again, is writing the prompt. There's the prompt right there. In my case, I'm using the selected object. I have the selected object that I select, and I just get the name from it. I'm using that to basically generate the description. I said, write a brief description of the selected object. And then I cite the references and format the response as an HTML. So pretty straightforward query. This is some of the new things, some things that they changed with it. With the 3.5 is you have to tell ChatGTP that it's a helpful assistant, and you can put the prompts in, and you can actually put a couple prompts in it. So, but that was the call. Pretty straightforward. Again, ChatGTP gave me most of the code for it. So,
thank you. It's funny that you use ChatGPT to ask it how you connect to ChatGPT.
I had heard that you could do that, and I was like, I tried it, and it's like, oh my god, I understand the code. So it was pretty fun. So.
Thank you once more for attending this webinar.
Take care, Martin.
Yeah.
Thank you very much.